Hello everybody. Today we're going to be talking about geometric probability. So this is going to be all about length, area, volume, that type of thing. So we're talking about measurements. Now it is probability. So when we talk about probability, we're talking about the total. Total. Okay? So what we want over the total. So just depending on what the scenario is. So let's look at this example. A point K is randomly selected from AE. Well, segment AE goes from here all the way to there, right? Okay. So what is the total length? So we have from A to B is 1, 2, 3, and we go all the way up to 8. Now what is the length of AC? So we have 1, 2, 3, 4, right? So the length is AC is 4. So find the probability that K is on AC. Well, that means we have what we want is 4 over my total, which is 8. And we simplify that, so it'd be 1 over 2. So the probability is 1/2. Oh, I don't want to move that. Oh, that moves. Wonderful. Alright. So, let's move that up, move this up, so we can actually see the other ones. Okay, so find the probability that K is on BC. Excuse me. So we BC, we count 1, 2, 3. So it'd be, whoops, I want there, 3 out of 8. CE, 1, 2, 3, 4. So it'd be 4 out of 8, which is 1/2. BD, 1, 2, 3, 4, 5 out of 8. And AE, well, the whole thing is AE is 8, whoops, and AE is 8, so it'd be 8 over 8, which is the probability is 1. So that is what we would be talking about, length and probability of length. So now we have a dartboard. So we see a dartboard here. We have a 10 by 10 dartboard. If it hits the board, what is the probability that it will land on the shaded part? So when you're talking about probability and you've given a picture, you want to say, what do you want? Well, this right here says we want it to be in the shaded area. So now these questions are going to help you lead to that. But we want the shaded over my total. So that's our goal. That's our end goal. So what is the area of the entire dartboard? So that's going to be my total. Well, it's a square. It's 10 by 10. So 10 times 10 is 100. So that's going to be my entire area. So the radius of the circle, so I'll draw it in here. So if we see the radius, it's going to be half the total, which is going to be 5. So the radius is 5. And what's the area of a circle? Hopefully we know pi r squared. So I do pi times 5 squared. And you punch that into your calculator. So 25 pi is 78.54. And then find the probability. Well, it says, what do we want? Well, we want the shaded area. Well, the shaded is my circle. So my area of my circle is 78.54. And my total, which I found earlier, was 100. And then that's going to be, I'm not going to have you simplify those because that's a little crazy. So this right here is just going to be my probability. My shaded over my total. So now, let's look at another example. So here is a rectangle with a triangle in the middle. So we want to find the probability of the shaded area, shaded region. Well, if we see the shaded is a triangle, right? So shaded and its probability over my total, and my shaded is going to be a triangle. So it says find the total area. Well, the total area is going to be a rectangle. So I know that the length is 5, and then I have to find this. So 3 plus 2 plus 3, 6, 7, 8. So 5 times 8 is going to be 40 is my total area. So I know that's going to be at the bottom. So now my shaded triangle is going to be 1/2 base times height, right? So it's bringing back all those geometry formulas. So I have 1/2, and what's my base? 2, and my height is 5. So my shaded area is 5. My probability, shaded, over my total, and that is my answer. And this one simplifies nicely, so I can do 1/8. Another example of finding geometric probability, of finding the shaded area. So here's another one. I have this problem. It says find the total area. So we want to find the area of a shaded. The total area is a circle, which is going to be pi r squared. Well, my radius, if the whole thing is 28, what is the radius then? 14. So pi times 14 squared. 14 squared times pi is 615.752. So that's going to be my total area. Now find the shaded area. So that is going to be a triangle. So my triangle is 1/2 base times height. Now it doesn't tell me what my base or my height is, but I do know that they're the same. Well, my base is going to be the radius. So that's 14. Excuse me. And the other one is 14. So 1/2 times 14 times 14 is 98. So my probability, shaded over my total, is going to be 98 over 615.752. And when there's decimals, we can just leave them just like this, because otherwise it gets kind of crazy when we try to simplify. Alright? So, let's move that up. So now here we don't have a picture. We want a picture, because otherwise it gets a little tricky. So you have a rectangular board that is 24 inches by 35 inches. In the center of the board is a hole with radius of 5 inches. So let's draw a picture here. A rectangular board that is 24 by 35. In the center of the board is a hole with a radius of 5. So we're playing bags. We want to find the area. So this right here is a radius of 5. So you can see my picture. It's not the greatest, but you can kind of see it. Find the probability that you throw a beanbag through that hole. So we want to find the total area first. So my total area is length times width, 24 times 35. 4 times 35 is 840. Find the area of success. Well, the success means you're getting it through the whole of the board. So that means I need to find the area of the circle, which is pi r squared, and my r is 5. So pi 5 squared, 78.54. So find the probability of what we want over the total. What we want is to have that be the area. So we want to get it in the hole, so 78.54 all over 840. And that is my probability. What we want over the total. The area of success over the total area. Alright, so you're going to get a few more examples on your homework. If you have more questions, I will be ready to answer them on Tuesday. And have a great long weekend, everybody.